In this lecture, we are studying FCC diatomic crystals. FCC diatomic crystals, and the example of FCC diatomic crystals are examples LH, KBr, RBI, MgO, MnO, and NaCl. These are the example of FCC diatomic crystals. Out of these examples, we are considering NaCl. NaCl crystal or Nacl structure for explanation purpose. This NaCl structure consists, the vast arrays of positively charged sodium ions and negatively charged chlorine ions. And this is described as, this NaCl structure is described as, can be described as two interpenetrating FCC monoatomic sublattices. One belongs to sodium and other belongs to chlorine. Okay, this is described as two interpenetrating FCC, of course monoatomic in this case, sublattices. Two FCC monoatomic sublattices are interpenetrating and then they are forming one FCC diatomic lattice in which one sublattice belongs to sodium ions and other belongs to chlorine ions. So these are the two sublattices are interpenetrating into each other and forming one lattice of FCC diatomic. Now, in each sublattice, we can draw one FCC unit cell. So in this case, I am first considering chlorine ion sublattice and drawing unit cell in that. So instead of showing the lattice, I am only showing here the unit cell. So this is the unit cell in the sublattice of chlorine. And the unit cell of chlorine in this case is FCC, face center. So in case of the face centered, the atoms are, let me show by red, at 8 corners and 6 face center. showing slightly smaller so that I can show all these 8 corner properly, and 6 face center. Bottom surface face center, top surface, side surface. This is a front surface and this one is for back surface. So this is the unit cell of chlorine ions. Then there is another unit cell of sodium ion. This is also FCC unit cell, and here in this case there are 8 corners sodium ions and 6 face center, front surface, back side surface. So this is unit cell of sodium ions. Okay, so this is the unit cell in chlorine sublattice, and this is the unit cell in sodium ion sublattice. So these two sublattices are interpenetrating into each other. How they are interpenetrating? Let's see. These two sublattices interpenetrating such that if chlorine ions is at if chlorine sublattice, if let us say if origin of chlorine sublattice is at 0, 0, 0, then origin of sodium sublattice is at A by 2, 0, 0. This is how these two sublattices are interpenetrating. Means if origin of this atom is at 0, 0, 0, then origin of this one is at A by 2, 0, 0. So these two are interpenetrating and form a lattice and unit cell of NaCl structure. The unit cell of NaCl structure looks like this, in which red are chlorine ions and greenish are sodium ions. Now we have to draw this unit cell. In exam, you have to draw the unit cell. So I am going to show you how to draw this unit cell first. Unit cell of NaCl. The unit cell of NaCl. Let us draw the unit cell of NaCl. It's very important to draw a perfect unit cell. So as you can see, this one is actually cube. Sky blue color is the cube. Now in this unit cell, if chlorine ions occupy all FCC positions, okay, in this case, if chlorine ions occupy all FCC positions. FCC positions are 8 corners and 6 face center. Then sodium ions occupy all octahedral whites. Now these octahedral whites are formed at the body center of the unit cell and at the midpoint of every edge. So before that, let me explain you what are the octahedral whites. In octahedral whites, octa means 8. That white is surrounded by 8 faces. And for that, there are 4 atoms in the same plane. One atom is above the in above plane and one is at below plane. So you can see that when we join this, 8 faces are formed in the plane below it. This is 1, 2, 3 and one backside. Similarly, 4 faces are formed on top of this. And at the center of this, there is a void. This void is surrounded by 8 faces. That's why it is called octahedral void. Here I have shown the diagram. This is the octahedral void. And these octahedral voids are formed at the body center and at the midpoint of every edge. So first let me show the position of ions in this unit cell. As I said, chlorine ions are occupying all the FCC positions. If so, These are the four corner atoms of lower surface, four corner atoms of upper surface. So these are the eight corner atoms and six face center atom. See, this point is the face center of the top surface. This point is face center of bottom surface, face center of side surface, and face center of this side surface. Now, if you see clearly, this is the face center of the front surface, and this is the face center of back side surface. So, in this diagram, I have shown chlorine ions which are occupying all the FCC positions. Then here sodium ions occupy all the octahedral positions. Now octahedral positions are formed at the body center. This is the body center. And as you can see, if you consider this body center atom, there are four atoms in the same plane. One, two, three, four. One above and one below. So this void is surrounded by eight faces because after joining these atoms, it will form four surfaces on top surface, four surfaces on top plane, and four on bottom plane. So this void where this sodium ion is surrounded by eight faces, and we call it octahedral void. Also, these octahedral voids are formed at midpoint of every edge. So this is the midpoint of this edge. Similarly, midpoint of this edge, midpoint of this edge, this edge, this edge. Total there are 12 edges. Okay, one is over here, one is here. Four here, four here, and four here, and one at body center. So this is the unit cell of NaCl. See, it looks just like this. This is NaCl. Now let us characterize the unit cell. Characterization of unit cell. We know that this is NaCl diatomic. Sorry, not NaCl diatomic, it is FCC diatomic. Then we have to find atomic basis for this. Atomic basis is two ions, chlorine ion and sodium ion per lattice point. So it is diatomic. Two ions per lattice point is the atomic basis. And if there is an atomic basis, we have to state orientation of atomic basis. Orientation of atomic basis is if chlorine ion is at 0, 0, 0, then sodium ion is at A by 2, 0, 0, or vice versa. They can change their position. In this case, if chlorine ions occupy all FCC positions, then sodium ions occupy all octahedral voids, or vice versa. It means if sodium ions occupy all the FCC positions, then chlorine ions occupy all the octahedral void. That is the way you can select the unit cell by both ways. So that is the orientation of atomic basis. Then effective atoms, or you can say ions, per unit cell. Effective ions per unit cell. Now in this unit cell, chlorine ions are occupying all the FCC positions. So for chlorine ion, all FCC positions are occupied, means there are 8 corners. Contribution of each 8 corner is 1 by 8. So 8 into 1 by 8. Plus there are 6 face center atoms. Contribution of each is half. So that is 4. So chlorine ions are 4 in the unit cell. Similarly, sodium ions. Sodium ions are at the midpoint of every edge. And you know that this edge is common for 4 unit cell. So this edge center ion is shared by 4 unit cells. So its contribution to the unit cell is 1 by 4. In cube there are 12 edges, plus there is one ion at body center which is not shared with any other unit cell. So its contribution is full, that is 1, and so 4. So there are 4 chlorine plus 4 sodium ions per unit cell, or you can say 4 NaCl molecule per unit cell. That is effective number of ions. Now in this case, these ions are in contact with each other, along the edge. Let me show you that diagram here. This is the actual diagram of the NaCl. The red are chlorine and this is sodium, and along the edge you can see here clearly that along the edge, any edge if you take, even this also, even this, even this, this, any edge you take, along the edge they are in contact with each other, and our edge is A. So along this edge they are in contact, and therefore A is equals to diameter of chlorine ion plus diameter of sodium ion. That is A. Forgot to mention the coordination number. Coordination number for this is 6. As you can see that in this case, every ion is surrounded by 6 opposite ions. For that, consider this body center. So this is the one, this is two, second, third, four. Four in one plane, one above and one below. Or you can see that in the octahedral height. All these are at the same distance. So four in the one plane, four above and four in one plane, one above and one below. So this ion, cation, is surrounded by six anions. So sodium is surrounded by six chlorine ions, or it can be chlorine ion surrounded by six sodium ions. And so the coordination number is 6. Then let's find packing factor. To find packing factor, we know in this unit cell there are 4 sodium and 4 chlorine. So in this case, it's a volume of 4 sodium ions plus volume of 4 chlorine ions divided by volume of unit cell. Volume of the sphere in terms of diameter is pi by 6 diameter cube. Okay, that is the volume of the sphere in terms of diameter. So in this case, volume of 4 sodium ions is 4 into pi by 6 diameter cube of sodium ion plus, this is plus 4 into pi by 6 diameter cube of chlorine ion divided by A cube. We know the value of A, this is the value of A. So divided by diameter of sodium plus diameter of chlorine cube. This we can simplify further by taking 4 pi by 6 common. Then in the bracket there is a diameter cube of sodium plus diameter cube of chlorine ion divided by diameter of sodium plus diameter of chlorine cube. This is the packing factor. Now we have found the lattice constant A and the packing factor for NaCl. But there are several materials which are having such FCC diatomic structure. So we can write in general formulas for all. In general, for FCC diatomic NaCl type, lattice constant is diameter of positive ion plus diameter of negative ion, and the packing factor is 4 pi by 6 diameter cube of positive ion plus diameter cube of negative ion divided by diameter of positive plus diameter of negative bracket cube. So using these formulas, you can find lattice constant and the packing factor.